Hello Cryosphere, it's time for another Winter Blue Ocean update. A Winter Blue Ocean event is when you have an entire year of no ice in the Arctic Ocean, and that means even an ice-free winter. So we will be looking at when we can expect the first full year with no ice. So this time I have both extent and volume, and that means both good news and bad news, if you will. And we'll return to the good and bad discussion at the end of this video. So first we have annual extent has gone up to 9.74 million square kilometers, and it's continuing its rise in May, and the current projection for the next month is that we will go higher than 2016 by August 17th, so that's a possibility. And from this chart you can also see that 2017 is lowest ever for annual extent. 2013 was the second lowest, and last year is third lowest at the end of May. And yeah, you can also see the current rate of increase is the highest since November 2013. So that's almost 4 years since we were rising this fast per day. And in the next slide you can see the same development as this one, but in a larger context with the past 14 years, all in this chart. And 2017 is down here. So to think a little bit outside the box, you can say in general that this year has been uneventful thus far until the start of the melt season. So this rise here seems to be melt season related. And if we look for similar events in the past, it doesn't really look like these years, 2007 and 2012, because they go up pretty much from the get-go, from the start of the year. And another year that starts a rise at the beginning of melt season is 2013, which is here. So you have the rise starting here, and I'm looking into the possibility that what we're seeing now is caused by this huge decline in annual extent that started in October 2016 here, which was actually bigger than the 2012 abrupt loss event. And the only event that is bigger than that again is the 27 record abrupt loss. You see here, we lost almost 400,000 cubic square kilometers of annual average sea ice extent. So the way I'm thinking here is that these are sort of tipping points, and you had one of those tipping points last autumn, which lost a lot of ice, and we are now record low, as you can see here, for annual extent. And it's a new situation in the Arctic Ocean where you have a lot warmer seas, and you have bigger areas of open water, and you have less volume, smaller thickness than you ever had. So I think what happened both in 2013 May and 2017 May is that you have all these edges around the Arctic Ocean with open water, and you have ice cracking up and dispersing, going into that open ocean, and then extent increases. So what may look, like we're getting more ice than last year, it may actually be that the sea ice in the Arctic Ocean is dispersing and getting prepared to melt even more and even faster. It may sound strange, but you have more areas of open water all around the Arctic Ocean, all around the North Pole, at the edges of the Arctic Ocean. So you have more, death zones, if you will, for the cracked up ice to go into and melt out in. So the question is, if we are in a 2013 sort of year or melt season, will we then go up very steeply like 2013 did for annual extent? And you can also see that 2013 went up much steeper than 2008. And that's maybe because that dispersal effect was stronger because of less sea ice. But with these tipping points and these, shifting stages of the meltdown, we may see another development of this, these increases in annual extent. You may see us in 2017 going up like this for a while, and then maybe collapsing from there in a way, turning around and going down, because maybe the ice is so thin now, and there's so little of it that you get to a breaking point where you can't actually go up all the way like this. But that's hard to tell, and the sea ice comes into new areas of or new territory of breaking up and going down. So we'll see. Maybe this is good for the ice, bad for the melt, or maybe the other way around. It's a bit hard to tell at this stage. So over to the bad news. You have the annual volume, which is going down, has been going down all year. We're now at 12.8 thousand cubic kilometers, and see, we are lowest ever. 2013 was the second lowest, and at the rate we are losing annual volume now per day, we would be out of all year sea ice by November 2026. So We'll look at that in the next slides. So here we have my glacier lake with different projections from the same app spread out in different sizes from the frequency of the projections, how often they come up. And November 26 is here. You see it only came up once, which was this time. And you have 2026, it's quite frequent. And by the rising annual extent graph, you get a never projection, which is has only come up from the annual extent app. And it says never is because the graph is going up, and that means it will never get to 0 sea ice. The most frequent year to come up in these projections is 2021, and it belongs to the 2020s, which is the most frequent decade to come up here. All of these projections are based on really short-term volume losses, and we have longer term losses in the next slide. Here you have the estimated time of arrival for the winter blue ocean based on 1 to 3 year current volume losses, and this is based on a linear projection of those same losses. And the y-axis here is the year of no ice, when we expect to have 0 ice for the entire year, including the winter. And this main blue field here is 24 to 29. That's when it says we will have no ice even in winter, and it's broken up on the 3-year trend says 2029, and the 2-year trend says 2024, and the 1-year trend says 2026. These are the blue field. So somewhere between 24 and 29, with a linear decline of Arctic sea ice volume, it will be at 0. And this black line is the half-year version of this, the half-year volume loss trend. And because it's such a short-term loss, it's more up and down. Currently it's outside of this chart at 2031, but that may be due to you have a record amount of snow on top of the ice, making it a bit harder for the satellites and the algorithms we use for them to figure out just how thick the sea ice is at the moment. And the reason snow is different from ice is that if it's really a lot of snow that is being counted as ice per now, you can't really fool the Arctic Ocean. So if that proves to be the case, we will see this black line coming down again into this chart later on in the melt season, because snow of course melts so much faster than ice. Alright, so I mentioned the linear part. There's really no reason to expect the final collapse of sea ice to be linear. It will be most likely either slower than linear or faster than linear. And in the case that we have a faster collapse than linear, we may have an accelerated collapse, which goes faster and faster the lower you go for sea ice volume and extent. So it could be even before this blue line. Okay, next slide. You have the annual volume from Pyomas on the left, and you can see we are closing in on the green trend line, sort of the middle line here, and that trend line is a polynomial trend going back all the way to 1979, and it will hit 0 in 2034. Then you have the short-term 2026 projection, that's down here, and for the longer 1 to 3 year trends you have 24 to 29, which is here. So that's what's projected by those apps at the moment. A faster and accelerated collapse would maybe be able to go down much closer to 2020. And to the right you have the annual extent, which looks very different. And here you have the sort of the good news, bad news dilemma, because here you can see that the red graph has bottomed out and it's now going up, visually going up, and it's heading up above the trend line again. And this green trend line hits 0 in about 200 years from now. You see the arrow popping up here, indicating the future. And yeah, so you can then a bit confusingly, you can have one graph for the same sea ice going up like this, and then you have the other graph going sharply down like this, which is the volume and the extent. So that's a puzzling situation where you have good news here and bad news here, but the real life ice that is melting is a three-dimensional sea ice volume or thickness swimming in the warming Arctic Ocean. So it doesn't help very much to have the surface ice dispersing to the side and going out into open water, preparing for a bigger melt. But it's an exciting situation, and we will certainly learn a bit more about how this progresses. So, final slide. I mentioned the good news and the bad news situation. Unfortunately, it may seem like even the good news with the annual extent going up is actually preparing for more bad news, if you will, with the dispersal and the faster melting out of the ice because it's spreading into warm water. That may or may not happen. But you also have the the concept of good news and bad news itself, where some people who are kind of secretly cheering on the ice to just melt out and be gone already for different reasons. They don't want to use the word good for this and that weather being good for ice melt because of, I guess, the terrible consequences of climate heating up that fast, and because of the consequences for human societies. But we shouldn't attach so much value to words like good and bad weather or a good or bad melt season. Because it's like if you're talking about good melt, that's not really saying that it will be good for everyone on the planet that the ice is melting out. It just means that, let's say, cloudy weather will slow down the melt, and that's bad for the melt. And you also have the possibility that a fast melt out of the Arctic Ocean sea ice may even lead to a collapse of human society, a collapse of civilization, which would, according to some people, be good news for the biosphere, for all the other living creatures living here. So it's not black and white. All right. Bye.